Okay. We can work with this. Okay, so having overcome those small little difficulties, let's just make sure that my presentation manager also works. Something works. That's good. Welcome to Wednesday afternoon, September 4, your first day on campus. My name is Professor Paul Delaney, and I will be your Master of Ceremonies for the fall term with respect to Physics 1410. My colleague, Dr. Elena Hyde, will be joining us in January, but you're stuck with... What? We'll go with that for the time being. So you're stuck with me for the fall term. The aim of today's exercise is to give you a bit of a sense of how the course is going to be administered, the things that you're going to be responsible for, the things hopefully that you're going to learn and enjoy, and then we will dive into Chapter 1. This is what your textbook is supposed to look like. It is in the bookstore. I went and checked. You can bench press several of them, so there's lots of good mass there for you. Of course, you can get it in hard copy, you can get it in a loose leaf variety, or you can get it as an e-text. Doesn't matter to me which version you prefer. All of them come packaged with something called Mastering Physics. We'll talk more about that in a moment. If you have a previous edition of this textbook, fine, not a problem. I have no issue with that. The differences between the 15th edition and the 14th edition, and probably the 13th edition, are relatively minimal. So if you have a second-hand copy of the 14th edition, that's fine. But you will still need to get an active license, an active subscription to Mastering Physics. Okay? All right, so some of the other logistics here. My name has already been given. Office hours, Tuesday afternoons from 2 until 3. My office is over in the Petrie Science and Engineering Building, sort of west of here by about 5 minutes. If that time slot does not work for you, by all means, arrange a time with me through the course email address, or if you see me wandering across campus, which is highly likely, then by all means stop me at that point in time. But as I say, normally speaking, Tuesday afternoons, that's the most convenient time because I'll be in my office. You can just drop in, no appointment necessary. But if that doesn't work, as I say, send an email to PHYS1410@yorku.ca and we'll make a mutually convenient time for us to get together. There is a laboratory component associated with this course. They run out of Bethune College, room 102, that's downstairs. 5 labs each term. A couple of things to note. It is administered separately from the lectures, from the theory part of this course, if you will. So while I am vaguely aware of what your labs are and when they are happening, vague is the operative word here. There will be a Moodle site set up for the physics labs themselves that will go live, I am told, on Friday. So at that point in time, it should appear in your list of Moodle courses. On there will be the information associated with when your labs start, and I can tell you that they will be starting the week of September 16, so not next week, the following week, but which day and what your lab is, that particular section, that will be on the Moodle site associated with the lab section, okay? So please don't ask me because I won't know, okay? That's what that Moodle site is associated with, and there is one of my colleagues, Professor Maneri, who is looking after that. You have his email there. So if there is something on that lab website, that Moodle site, that makes no sense, speak to him. Okay? So labs start the week of September 16. Okay? 5 this term, 5 next term. On Moodle, our Moodle site, the one that I'm looking after this term, Professor Hyde will be looking after next term, that's where lots and lots of information will be found about the lectures. Now, all of you should have received an email broadcast from me. I can't remember whether it was yesterday or the day before, but you should have received an announcement from me. You'll get those about once a week. pertinent information associated with how things are going in the class, which chapter we're up to, if there is something noteworthy that you need to be aware of, and so on. That's what the announcement broadcast is all about. It's going to your primary email address, so whatever you declared to be your primary email contact, that's where those announcements are going. On the Moodle site, there is a discussion forum that is available for you to post questions that I will be able to answer, or more to the point, anybody in this room could conceivably answer. If I've said something in class that doesn't make a great deal of sense, if there is something in the textbook that needs a bit of clarification, post it to the discussion forum and let somebody answer it. And if nobody answers it, I'll answer it. Or if somebody answers it and they answer it wrongly, I'll correct it. But the discussion forum is designed to give you an opportunity to have other like minds looking at a problem and answering a question. Okay? As I said, if it doesn't get a good answer in a reasonable amount of time, within 24 hours, then I or one of our TAs will certainly pop on and answer it accordingly. Okay, so the Moodle site is a one-stop shop. If you haven't logged into Moodle yet for this course, I strongly recommend that you do, because amongst other things, the slides associated with Chapter 1, which we're going to be starting shortly, are already there. I will make it a point of posting those chapters in and around the beginning of each chapter. And of course, we're recording this, meaning that you'll be able to review from the lecture recording aspect what we've gone through in the class. So all of that is sitting on the Moodle site. Okay, you're probably all wanting to know what the course assessment is all about. A number of differing elements. And the main aim is to give you an opportunity to excel. You know, if you like doing homework assignments, if you like doing labs, you'll do very, very well in those components. Maybe your strength is not the midterms. Maybe your strength is associated with the final. Maybe you're a real eye-clicker fiend and you're able to do those really well. There's a variety of differing assessment elements spread throughout both terms that allows you maximum opportunity to excel in the course. Or conversely, you can have a bad day and it's not going to destroy your mark. And so you can see here that we've got a couple of midterms worth 10% each, a couple of final exams, they're worth 25%, and in between time, homework 15%, in-class clicker activity 5%, labs 10%. A little more clarification. Those midterms, one of them is already set for you, October 26, as I recall. The February midterm is not set yet. Please note, October 26th is a Saturday. Yes, I know, Saturday. Who wants to do a physics test on a Saturday? Well, the answer is this class does. Because there is no way we can actually write the test in here comfortably in the middle of the week. So what we end up doing is taking over a Saturday. It's a little calmer. You don't have to get up early. We do it, and then you've got the rest of the Saturday free. If that date cannot fit your schedule for whatever reason, please contact me. Whatever reason does not include, I don't want to do it that day. Okay? If there is a religious observance, if you can't get out of work, you're going on a trip to Paris or something, okay? Contact me. Otherwise, we will all be together in Curtis Lecture Hall I that day for the midterm. The material that midterm will be covering will be everything up to the preceding week, nominally speaking, probably the first 6 chapters of the course. We will be going through the textbook, nominally speaking, a chapter a week. And so that midterm is about 6 weeks away, so I expect that the midterm will cover the first 6 chapters. It'll be a mix of multiple choice questions and relatively short answer type calculation questions. Same thing in the February. That midterm will cover everything that Professor Hyde does during January and into February. And then in our case, for the fall term in December, it will cover anything that we've done in class with an emphasis on the material that we have done since the midterm. That is to say, the December exam is cumulative. It will include questions from the material that we'll be doing from now to the midterm, but there'll be less emphasis on that because I've obviously already assessed you, examined you in some capacity. The December exam will have an emphasis on the second half of the term, but you're not allowed to forget what we do in the first half of the term. Okay? I can't tell you the date for the December exam yet because the university sets that date. There's an exam period and all of those dates go into a big machine and spits out a date for us. The moment I know, you will know as far as the December exam is concerned. Okay? The homework assignments. They are going to be done through this Mastering Physics. And the first one is already available for you. So obviously chapter 1, and it requires you to log into Mastering Physics. Okay? Once you're in there, you'll see all sorts of learning aids and support for the course, and you'll see the homework assignments. The homework assignments will be coming 1 per week. Okay? So it's fairly busy in that regard. The aim of the exercise is that I don't want you to wait until the night before the midterm or the night before the final before you start reviewing the material. Not a good way to remember anything. So the homework assignments will be based upon the chapters that we will complete. They'll be due Wednesdays at 10 o'clock in the evening, and they will cover the previous chapter. So chapter 1's homework assignment is due next Wednesday evening at 10 o'clock. Not 10:01, not 10:02, but by 10 o'clock. If you want to finish it today, that's fine. Okay? Don't wait to 9:59 next Wednesday before you hit enter and complete the assignment. Because the moment 10 o'clock rocks around, the quiz, well, it's not a quiz, the homework assignment closes, and if you haven't submitted, that is a nice round number for you, 0. Okay? So you have to submit on time. As a consequence, there are about 12 assignments in the fall term, 12 assignments in the winter term. The 85% rule will apply. What that means is that I will take, the best 85% of all of your homework assignment marks and count that towards 100% of the assessment. It means that you can miss a couple of homework assignments. It doesn't penalize you. It means you can have a bad week. You didn't like that chapter and you just did badly on the homework assignment. That's fine. 85% of 12 basically is around about 9 or 10. So for the 12 homework assignments this term, 2, maybe 3, will be discarded. Your best 9 or 10 will be taken for your mark this term and obviously double that for the next term. So you can miss an assignment. I'm not recommending it, but you can, and it doesn't impact your mark. You can have a bad assignment, and it doesn't impact your mark. Okay? So if, for whatever reason, you miss the submission of an assignment, don't worry about it. Obviously, if something of a more significant nature happens that precludes you from attending your duties in the course for, say, 2, 3, or 4 weeks, I hope that doesn't happen, but sometimes things do happen. Contact me. We will make appropriate arrangements. Okay? But missing one because you slept in and forgot to hit enter or whatever, don't worry about it. Move on. Okay? That's for the homework. The in-class clicker questions. As we're going through the material in the class, there will pop up 2 or 3 questions that I will ask you. Those questions will pertain literally to the immediate material that we've just completed. So roughly speaking, every 10 to 15 minutes in a class, I'll throw a question at you. And it will be associated with the previous 10 to 15 minutes worth of work. And it will test your understanding. Now, you can see that the clicker marks aren't worth a lot. Okay? They are handy though, trust me. When it comes to April and we're doing all the calculations, that 5% might make the difference between your B and B+, between your C and C+, and so on. So don't blow them off. But their main use is to assess for you whether or not you understood what I've just been talking about. So you'll take the question, you'll use your clicker, which is any device, a laptop, a phone, a tablet, any device. Load the clicker software on there. That information is in the course outline. It's also on the main York website. And when the time comes up for the polling of the question, you'll answer it. I record all that information, and then we post the marks. But it's for you to figure out whether or not, yeah, that point really makes sense, and you get the question right, or, my gosh, it doesn't make sense. And I'll see that result. I will see it anonymously initially, so that if there are 4 options, and option A is the correct one, and everybody answers D, obviously I've done something wrong in my explanation. And so we will stop right there and then, and we will go back through it and find out what it was that I confused you with. Okay? So those questions will come up, as I say, 2, 3, maybe 4 in a class. At the end of the term, same thing. If I've asked you 100 questions, 85% of them will count, so 85 of those 100 questions represents full marks. You can blow 15 answers in that scenario. You can be absent for up to 15 questions and still not impact your mark. Okay? So that's what the 85% rule is all about. It applies to the homework and it applies to the clicker questions. The lab's completely independent, as I said, of the course. You must pass the lab component and you must pass the lecturing component to pass the course. Okay, so Physics 1410, you have to get at least 5 out of 10 on the labs, and you have to get at least 50%, which will be in this particular instance 45 out of 90 on the lectures. That represents a minimum pass on both components of 1410. Okay? Right, so that's all the assessment stuff. I think I've covered everything I wanted to do there. Yes, okay. Right. I do recommend that you have a textbook. I'm not saying that it has to be the hard copy. If you're much happier with the e-text, that's fine. If you've got a second-hand copy of a current physics textbook, that's fine too. But I do recommend that you have a textbook of some description to supplement my notes and what I'm telling you. Everything in my notes is in the textbook. Not everything that's in the textbook is in my notes. Okay? There are sections within the textbook where we're just not going to cover it. For example, if there are any examples to do with integration, not going to touch it. I will touch a little bit on differentiation, but I'm not going to touch anything on integration. There is information in the textbook about integration of various physics concepts. Not touching it. For those of you who are interested, it's there. I'm just not going to examine it. I won't go through it in class. So, the textbook is a great resource, lots and lots and lots of examples. It expresses information subtly differently to the way I do it. So I do strongly recommend that you have a textbook. Okay? But it doesn't have to be the current 15th edition of Friedman and Company. You do have to have a Mastering Physics, as I said. That is set up independent of, well, it's set up by Pearson Publishing. That's where additional resources are. That's where your homework assignments will be located, and so on. That's the licensing that you need to have. If you buy the current textbook, the licensing is included. If you have a textbook, you'll have to pick up the licensing separately. A caution here, if you are buying the license for Mastering Physics independent of the bookstore, okay, that's cool. Just be careful. Last year on the website, they were charging in US dollars. And so some people accidentally bought it through the site only to realize that it was US, and by the time it converted to Canadian, you know, it was add a gazillion dollars to it compared to over at the bookstore. So if you are going to buy through the website, the Mastering Physics license, just make sure that it's Canadian dollars that you're buying and it's no more than what the bookstore is offering. Our course ID is right there, 17829. Okay, so once you've created your mastering account, go find that course because that's where all of the information will be. As I said, the assignments are due Wednesday evenings. Nominally, if for whatever reason we get off track, I'll obviously notify you, but the plan is each week, 10 p.m. Wednesday night, so that you get into that rhythm and it doesn't impact your weekends unduly. Okay? We've spoken about the 85% rule in this regard.
When are the new assignments posted?
Normally on the day that the current assignment is completing. So it's up for assignment 1. I will post assignment 2 next Wednesday because assignment 1 closes Wednesday night. I don't want you to get overwhelmed here. So normally every week.
And it just switched. Yeah, I don't know what happened.
What the? Oh, no. That's not right. Okay. Gremlins in the house. Stand by here, people. Let's try this again. Okay. Oh. Let's show from.
What if this place and just switch them on?
Display settings, huh?
Oh, it was actually in the PowerPoint.
Okay.
At the top, on the
Left-hand side.
display setting, one in the middle.
Oh, right. Okay.
Can't click power.
Easy for you to say.
Yeah. Small percentage.
Don't leave the front row, okay? Right. Okay. Obviously very talented with PowerPoint. Okay. And they're not badly overlapping. Oh, that's really good. Okay, I like that. All right, okay. So, I think we've just about finished all of this administrivia. We've spoken about the clickers, the 85% rule. That is the iClicker account ID. This is all posted, so, you know. Physics 1410, Physical Sciences 1920. We're not going to do any clicker questions today. We will do some sample clicker questions on Friday. So download the clicker app by then so that we can practice together. The real questions start on Monday. So Friday is a practice run, just like I'm practicing here with the PowerPoint presentation. Friday we will practice a couple of clicker questions. Okay? And yes, Monday is when we start the real stuff. Okay. How much time do you need to spend on the course? Well, the answer is, generally speaking, 7 to 10 hours outside of lectures. This is a job. If you're a full-time student, it's a job. If you're carrying 4 courses, then you should expect of order 10 hours a week on each of the courses. Everybody's going to be different. Some people might be able to get by with less time on the material. Some people will require more time. This is just a ballpark figure. If you're after a good mark in this course, B, A, obviously that number of hours may need to go up. If you're not so concerned about a good mark and a D is fine, well, maybe it's a... Seriously? Okay. Can you explain to me why it does that? That is, I have never... Anyway, at least one of them is still up. That's fine. So if you're interested in good marks, obviously more time is going to be required. So your decision, your pacing. But as I said, this is a job really, and if you want to get good results from it, you need time invested in it. I will also suggest to you that generally speaking, attending the lectures is very beneficial. I know, it's 5:30 in the evening, and gremlins in the house. Remember, by the way, science is not engineering. Okay, this is engineering. Software or hardware, it's not science. Yes, it's computer science. Emphasis in inverted commas on the sciences in computer science. If you are attending class, excluding the excitement that is happening with the screens, you're generally focusing on the material that's associated with the differing chapters that I'm presenting. So the concepts are there, they're flowing over you, you're listening to it, it's a good focus. If you say, oh, I've got it on lecture record, I'll catch it afterwards, I'll tell you right now, you won't go back and listen to it. You'll skip through it just to see, yes, he did this, he did this, he did that, but you won't listen to it, which means you lose that time of focusing on the material. Those students who attend class and aren't just sitting there on social media, but are actually attending class and you're with me and you're listening to the material, generally speaking, are a full grade point better in their final result. So if the average for the class is sort of C+, then those people who have been attending the class tend to be in the B+ range, and those people who have not end up in the D+ range. I don't do anything there. It's just the statistics, because you're taking the time to focus on the material. If you don't want to come to class, that's fine. You're not going to hurt my feelings. But it's up to you whether or not you're serious about trying to get a good mark. If you want to come to class and just watch the episode from whatever last night, don't bother coming to class. You can go do that at Tim Hortons or Starbucks or what have you. Focus on the material that we're presenting. The chances are really good that you will improve your mark considerably. Okay, I think that's all. Not that I'm going to be able to see to the back of the room, but are there any questions on what we've just gone through? If there are, sing them out, because as I say, back of the room, I'm not going to see you. Any questions about what we've done? You still put up your hand. Yep. I certainly do. Yep. Writing it down is just another way of reinforcing the material, okay? Don't take them down verbatim. Don't take what I say verbatim. But if you are processing that material and writing it out, it's another sense that you're using to process the material. Listening, seeing, writing. This is what I mean by if you're in class doing that, you're going to understand the material better.
Will you be providing a list of the sections not covered?
Absolutely. Absolutely. If there is a section in the chapter that we're not covering, you will be the second person to know. I'll be the first. Okay? So not a problem there at all. Also, you do not have to memorize any equations. Every single equation that I put up on these notes will appear on your midterm and your final. You'll have to figure out which one you want to use, okay? But they'll all be there in exactly the same nomenclature and exactly the same format that you see them here.
Could you help me please print a clicker question, like 11 by 17?
You want them nice and big?
Yeah.
Okay? We can do that.
Oh, thank
Yep.
you.
Yep. Yep.
Are constants also on that?
Constants, yes. You don't have to memorize constants or equations. You just have to know how to use them. Yes, sir. Again.
I assume that slight differences in the answer due to, say, putting the full versus rounded form of, like, say you need the speed to calculate, I don't know, the distance. And there's a slight difference when you put the actual speed, like, stored in the calculator versus running it off like 2 or 3 digits.
So part of chapter 1 is significant figures and the correct use of significant figures. So if you are dealing with elements in an equation which have, say, 2 significant figures, and you give me 17 from your calculator, you will be penalized. Okay? So it's not an issue of rounding, it's an exercise associated with understanding the value associated with significant figures in a calculation.
Even if you have the significant figures in the final answer, but through an intermediate step that you need the something from, like it's kind of ambiguous, like to me sometimes, whether you should hook that to 2 significant digits, or if you should use the full figure, and then at the end, write the 2 significant digits.
Let me just generically say at the moment that if there is a question where, as you're working through, you make some sort of mistake which gets transported to the end, where you make the mistake, you'll be penalized, but if you carry the wrong information correctly through to the end, you won't be further penalized. Okay? So when you're in mastering physics, you do have to be very careful about the way you answer the questions. And there are a couple of mastering primers that are already active and on the website, on the Moodle, not the Moodle site, on the mastering site, for you to practice just those sorts of things so that you get it right. If something happens during an assignment and it looks as if, in your opinion, it's wrong, you bring it to my attention during an office hour, I can override any mark in mastering, okay? It really depends on the situation. Same statement goes for the midterm and the final exams. The TAs will have some margin of latitude associated with the markings for the roundings. But as I say, if there are nominally 3 significant figures in the answer and you give me 17, I'm sorry, that's wrong, okay? All right, and I'll walk all the way up here just to make sure that there's nobody else. Yep. Sorry, did you get an email? Just speak up a little bit. On the announcement from the website? Okay. Tell you what, when I get home tonight, I'll send out one more. It might have been associated with a toggle associated with the beginning of term, or maybe your registration in the course wasn't processed properly. Let me send one more now that term has started, and if you don't get it, speak with me on Friday. Okay, so I'll send out one more to everybody that more or less is just hi. Okay, and if you don't get that, speak to me on Friday. Don't deluge my inbox for the time being, okay, because I suspect it's just a matter of the beginning of the term sorting itself out.
How much modern physics are we doing with classical?
Not much. Mostly in the second term. The first term is almost exclusively what we will call classical physics. The second term, depending upon how things go with Professor Hyde, you may end up with a little bit of quantum mechanics, a little bit of nuclear physics. That will be up to her. Sorry, you're stuck with history primarily with me. It's important, but it's more classical material in the first term. Okay. More or less. Yes?
You mentioned something about 45 out of 90 for the lecture. Is that the question?
So 100% represents all the marks associated with the course. 10% of that is associated with the labs. 90% is associated with here. So you have to get at least 5 out of the 10 marks in the labs, and you've got to get at least 45 out of the 90 that's associated with the lecture. That's where I was getting that. I just want you to be aware that you have to pass both components. You can't get, for example, let me make sure I do the arithmetic here, 34 out of 90 associated with 39 out of 90 associated with the lecture, and you get 10 out of 10 associated with the labs. That will bring you up to 49 out of 100. That's a fail. Okay? So you have to pass both the lecture component, which comes to 90% of your assessment, and the lab component, which is 10%. Which, by the way, is pretty easy to do. It's not a terribly hard constraint, but I do want you to be aware. Yep.
Calculators are allowed?
Sure. Yep.
Non-programmable calculators?
No, I don't really care if you've got time to do a program in while you're doing my exams. All power to you. But they cannot be internet enabled. Okay? If you have a calculator that can reach out to the internet, don't bring it. Okay? Just like your phone, when it comes to the midterm and the final exam, bury it in your briefcase.
What about graphing?
It's a handy trait to have, but you will be doing next to none of that here. You'll be interpreting graphs, and in the labs, there may be times where you are actually drawing up the results graphically, but within this course, there'll be, I don't think, any occasion where you're actually creating a graph. Okay, yes? You're quite determined to make sure I don't lecture, right? Yeah.
Will the lecture slides be posted before the actual lecture?
Normally, yes. Okay, they should. Okay, does this tell me that the lecture, today's lecture, is not sitting on the Moodle site?
It's up.
It is up. Oh, good. Right. Oh, phew. Okay. Yeah, right. Yes. The plan is, generally speaking, the day before we actually start a new chapter, that's when the slides will appear. Okay. And if for whatever reason we go through the material and there's an error in there, or I get partway through it and I decide, we don't need that, then I will amend those slides after we've completed the chapter. Okay. So think of what is posted initially as a preliminary It's probably going to be the final, but if something happens while we're going through the class, I'll repost it. The power of Moodle. Okay. I'm going to go with, and I see I have two interesting slide formats again. Okay, I really got to sort that one out sometime. Okay, so, in fact, this is more or less a summary of where we're at, or where we will be at in this particular chapter, talking about physics in general terms, how best to approach differing problems for a correct solution. Oh, by the way, we have a tutorial hour at 12:30 on Tuesdays. That's over in Lassonde A. That's where we'll be going through differing problems. I will post the problems that we're going through. You're more than welcome to come along, have a look at these problems, ask questions, and so on. The tutorial is not compulsory, but I do recommend them. Okay, so how we actually solve problems, working through it. We'll be talking a little bit about vectors and the difference between vectors and scalars, and then we will be talking about scalar products and vector cross products and so on. A lot of this should look very familiar to you from high school. Not surprisingly, physics is an experimental science. We make observations, and from those observations we try to formulate a model, a theory associated with the observations that we have made. The scientific method, in fact, calls for those observations to be carefully examined, for a theory to be developed, or a hypothesis initially, and then a new test of that hypothesis to see whether or not we've understood the process that we are actually observing. We make that experimental test, we collect the answers and see whether or not it supports, validates, or invalidates the hypothesis that we have put forward. Experimental science requires this careful attention to what the natural phenomena is that we are observing. If our hypothesis is testable on many occasions and is found to be a good match to the observations, that it can predict accurately under a variety of circumstances, then it might be graduated or elevated to a physical law, or indeed a physical principle. So when we talk about Newton's law of gravity, well, it just means that the postulates associated with understanding gravity have been tested on numerous occasions and have found to be very, very accurate. Einstein's theory of relativity. We continue to test all of these things right up until today. You can always stand the chance of invalidating a theory, but until you test it, you won't know. And if that theory requires a modification, if the observations require a modification to the theory, so be it. That's why we continue to test. So physics is front and center an experimental science. As we are working through problems, there are a number of different ways that you can proceed. Now, this is the one that this particular textbook uses. I'm not going to say it's better or worse than any other mechanism, but I see, so as to speak. You identify the information that you are given. So if I give you a problem which has got velocity and mass and force and directional information, you put all that down. It's likely, not guaranteed, but it's likely the information that I provided to you is essential for solving the problem. So you identify the information that you are given, the raw materials, if you will, associated with a given problem. And then you set up the problem. You look at the variables, you look at the question that's being asked, and generally speaking, it will alert you to, that probably is something to do with this equation, this physical phenomena. The information that you've been given, coupled with the direction that the question is asking you, will require you to set up some sort of framework that should lead to an answer. And obviously, at that point in time, you want to execute your theory. You've got an idea, you now plug in your variables if it's an equation. If it's a theory that you're trying to determine, does that represent the observation that I've made? You write out a couple of sentences. Whatever is the executable is based upon what you have set up, which is in turn based upon the information that is available to you in the question. But you're not done just because you get an answer. You need to look at that answer critically. If, for example, you're doing a calculation that determines the mass of a human being for whatever the problem is, and you conclude that the mass is 327,000 kilograms, you should look at that and go, maybe not, okay? You've got to keep a reasonable distance from your answer. Just because your calculator gives you a number doesn't mean that that answer is correct. Now, obviously, the difference between 3.4 and 4.7, okay, you're not going to be able to tell the difference. It might have been a rounding error. There might have been some silly little mistake you've made. You're not going to be able to pick that up with this evaluation. But order of magnitude type answers are really helpful to give you a confidence, a sense that the answer you have determined is, in fact, a reasonable answer to the problem that is in front of you. In physics, we often try to simplify things. The real world is a complex arrangement. Just for example, you throw a baseball. Well, you think that could be a really simple modeling exercise. Except that for anybody who's played baseball, you know full well that a baseball tends to move and swerve through the air because it's not a smooth surface, because there is wind that is blowing, because gravity is acting, because there's probably a spin that's been imparted on the ball, potentially by the pitcher. It actually is a surprisingly complex arrangement. And so if you're trying to determine the motion of the baseball, the first approximation will be a bit of a challenge. So rather than this sort of three-dimensional object, we often turn it into a point source, and we make various assumptions. Obviously, for example, the baseball is not going to vary very much with respect to the center of the earth. You know, you throw a baseball at sort of this height, maybe say 1 to 2 meters above the ground, and then it gets to the gets to the catcher, and it might be half a meter to a meter above the ground. So the total change in elevation might only be a meter. Gravitational field strength is not going to change much in that 1 meter. So you ignore variations associated with gravity. We can make a further simplification and say, there's no air. We're throwing it through a vacuum. So there's no action on the ball associated with air, and so on. When you are creating your problem or trying to set up for the answer of your problem, be mindful of the fact that you may have to make approximations. And if you do make an approximation, make sure you tell me about it. Okay? If it's in a homework, well, not so much in a homework assignment, but if it's in a midterm or a final and you've made an assumption because it seems a reasonable assumption, you make sure you put it there. You tell me why you've made this assumption. But in physics, perhaps more so than almost any other science, simplifying a complex system so that you have a better opportunity to solve whatever the problem is commonplace. There are a number of differing units that we work with. In fact, there are three very, very fundamental units: mass, length, and time. Mass we measure from the SI, or the System International units, we measure that in kilograms. We measure length in meters. We measure time in seconds. Those are fundamental intrinsic quantities. Now, we tend in science to use SI, these units. That's not the only set of units that are out there. If you go south of the border into the United States and other parts of the world as well, then, for example, length is often now in inches or feet. When you're looking at mass, it might be in pounds. Time is still seconds. It's a good thought, and it isn't. It's the only fundamental unit which is actually measured in kilograms rather than grams.
And I assume that for seconds, it's not really like, you don't say kiloseconds, you talk about times in like hours and days, right?
Well, hold that thought because we're going to talk about larger quantities, not today, but next time. But the answer is you could actually express something as 3,227 seconds or 3 kiloseconds. Generally speaking, I would suggest that you don't tend to use hours and days, but let's face it, kilometers per hour for a speed is pretty common and so on. We'll talk a little bit more about unit conversions later on within the SI structure. Okay? But the three fundamental quantities for the moment: length, mass, and time. For the longest time, we were able to define these fundamental quantities based upon physical structures. And so well, not so much in the case of time, but when it came to mass and length, we actually had physical entities that represented this is 1 meter, this is 1 kilogram, and so on. But of course, those physical entities could only exist in one location, tended to be in Paris. Now, the three fundamental quantities are all verifiable, all measurable in a laboratory setting anywhere in the world. So for example, when it comes to measuring the length of time for a second, we utilize, generally speaking, the cesium-133 atom. Now, when I say we, you're not going to go home and grab some cesium and fire a laser at it and measure the second, so it's not that easy to do. But you can set yourself up in a laboratory and you can go ahead and measure 1 second. And you do so by shooting a laser at the cesium-133 atom, and when the frequency, the energy of the light that is pounding the cesium-133 moves its electron in its outer shell from one hyperfine ground state to the other, and in the process reversing its spin, then that is a very, very, very specific frequency. 9,192,631,770 hertz is the exact frequency that allows that transition to be enacted by the cesium-133. So it means that that number of periods associated with light, when that number of periods has elapsed, 1 second has transpired. Sounds complicated? Bottom line to it, though, is it is an experimentally verifiable quantity that you could do here in a laboratory, that you could do in Europe, you could do down in Australia, you could do it anywhere. And it's based upon a natural element, cesium-133, and the amount of light or energy that causes a very explicit and unique transition to take place. We'll carry on next time and talk more about mass and length and the rest of Chapter 1. We'll see you on Friday, folks.